Welcome America, India, and Taylor Swift. So I would like to show you guys today my new friend who lives in India has a math channel for shortcuts in math. So here we've got all different ways to multiply two-digit numbers without multiplication. So this page is called Mathematics by Akash. And you know, if you forgot, let's go to my channel.
Okay, welcome viewers to the Helming Closet Tour.
There we go, and let's review. We've got a pre-calculus playlists by unit, right? So right now we're in unit 3, so this is Trig Identities. So any videos that I'm uploading go in that folder. Same for geometry. 1, 2, 3, 4, 5, they go in order. I've got a couple Algebra 2 ones, a couple Algebra 1 ones, not much, but anytime I find something that applies to those, I just add them in. All right. So let's go to the problems that we're doing today for review. Where are they? And we are going to start with problem 6. Hopefully I'll remember to attach this worksheet. So we already did 2 and 4. We did a quick review of inverse trig. For number 6, I thought we should record this one because we need to start on the inside here, just like we did the previous ones. So we go ahead and let's see if we can identify where this triangle is. The inverse cosine of 1/2. So first we restrict the range. 1/2, that's positive. So what quadrant does that tell us it's going to be in? Cosine is x. Where is x positive? Quadrant 1 or quadrant 2?
Quadrant 1.
Quadrant 1. So where this is also 1/2 means the x distance is the short distance. So that's going to be tall angle or short angle. The x distance is going to be short. So it's going to be a tall angle, right? And what angle is that in quadrant 1? What's the tall angle in quadrant 1? Pi over 3. So now what I'm going to do is I'm just going to rewrite this as the tangent of pi over 3. What's the tangent of pi over 3? We have it memorized.
Square root 3.
Done. Number 8 is different because when we did number 6, the inverse cosine of 1/2 is actually on the unit circle. The inverse tangent of 5/2 is not on the unit circle. So we're just going to have to draw ourselves a triangle. So we start the same way. We go ahead and restrict the range of where is the tangent positive? It's going to be in quadrant 1 or quadrant 4. Okay, so I'll just go ahead and draw myself a triangle. And tangent, this is 5 over 2, so that's going to be opposite over adjacent, or y over x, so 5 over 2. Now I need to figure out, using Pythagorean theorem, the measure of this, I'm calling it the radius, or if it's a triangle, you can think of it as the hypotenuse, but remember, these points are on the circle, so this is considered the radius. So if I say, let's find the radius, we Pythagorean theorem it, and you don't have to go through this if you know how to do this. 2 squared, a squared plus b squared equals c squared. So that's 4 plus 25, 29. So the radius is root 29. Now that does anyone have any questions on how to make the triangle? Making that triangle is the hardest part, I think, in the previous unit and also in this unit. But now that we have the triangle, okay, it's asking what's the sine of this angle right here. The sine is y over the radius, or opposite over hypotenuse, back from geometry. So that's just going to be 5 over root 29, which we can't leave that way. We need to rationalize. So we multiply by root 29 over root 29, and we get 5 root 29 over 29. Done. Questions? Can we move to the trig identities? Everyone have this written down? I'd like to do at least one. My video's only 4 minutes, so we got time. Trig identities they're just tough. They're new, they're tough. Some people love trig. Is anyone in here love trig identities yet?
Yeah, okay.
Wyatt? He's like, no. They're okay. Okay, I'll take it. I'll take it. They're okay. So For number 9, there's a lot going on the left side here. Remember, we're working on one side. First thing I notice is there are 2 terms because they're separated by a plus. Each of those terms have a sign. So I'm just gonna factor maybe one out, see what happens. What's left? Sine cubed becomes sine squared. Good with that? Factor out a sine. Now, what's sine squared plus cosine squared equal? Using our Pythagorean identity, 1. So this is just the sine of x. And notice I'm working down. This is how I'm trying to model what I want to see in your work. Sine of x times 1, that's just a sine of x. And now our left side equals our right side. So I'll go ahead and write that and then verify it. Check. All right, I'm gonna move on to the last one. So first thing I'm gonna do is rewrite secant, because I don't know, start there. 1 over cosine of x times sine squared of x plus cosine of x equals secant. All right, so this is sine squared over cosine. This is cosine over 1. I can't add those 2 fractions together until the denominators are the same. So I'm going to make this denominator, I'm going to make this equals out here. I'm going to multiply, or here, I'm going to make this denominator a cosine. So I'm going to multiply this by cosine of x over cosine of x. So I'm going to rewrite this. Sine squared of x over cosine of x plus, now I've got cosine squared of x over cosine of x. Well, now I've got 2 fractions that have the same denominator, so I can add them together. When I do that, what's the numerator going to be?
1.
Because it's sine squared plus cosine squared. So that's just going to be a 1 over cosine. 1 over cosine. And that is equal to the secant. So I'll just write secant of x equals secant of x, check. Sometimes I put my check on the side, sometimes I put it right by the equal sign.